I hope we are all right here and we are watching. Thanks for watching this another episode of Physics live stream. I hope you will enjoy this session. And I'm really sorry if you are here and the session didn't start. We're 8 minutes behind time. Really sorry about that. And today I have actually added on a small feature over here to actually, it's called a theory session so that you get a little bit of revision with the theory and not to be overwhelmed by the questions and just questions, okay? So I hope you enjoy this session over here and let's start the session immediately. Oh, before that, I would like to try out our small feature over here. I will play some background music and if the music is too loud, please tell me so, okay? And yeah, please tell me so. And yep, let's see how it goes today. See. Right.
Faces all that I see.
The music is too loud and disrupting, and please tell me so, okay? Right. Seems like things are okay. Yep. Alright, fantastic. Okay. Yep. Can anyone tell me the music is alright? Yeah, if it's not okay, then we'll come back later for that. Okay, let's do it. Yay. Yep, now I see you guys. Okay, so let's start the first session today, and today we'll start with a little bit of theory time first. That we will talk about latent heat, theory time about latent heat. Latent heat sebenarnya dia juga dinamakan dalam bahasa Melayu ialah haba pendam. Haba pendam ini apa maksudnya? Perkataan pendam itu sudah tunjukkan haba ini seperti dia terpendam. Haba ini hanya akan ada actionnya semasa berlaku perubahan jiring. Okay? Contohnya daripada pepejal from a solid to liquid kepada cecair. Okay? Daripada solid to liquid, daripada pepejal ke cecair, dia akan berlakunya ada haba pendam ini akan take action. Dan bagaimana ia take action ialah dia diberi oleh formula Q sama dengan ml. M ini ialah jisim, L ini ialah haba pendam. Okay? Q itu seperti biasa, Q ialah haba, okay? M ialah jisim, L ialah haba pendam. Haba pendam terbahagi kepada banyak jenis. Ada haba pendam penguapan, ada haba pendam evaporation, latent heat of evaporation, ada haba pendam pelakuran, latent heat of fission, okay? Iaitu melting ataupun solidification dan lain-lain, okay? So, tetapi kita akan tengok hari ini campuran soalan haba pendam dengan campuran soalan muatan haba tentu, iaitu topik daripada hari itu, dan dua-dua ini mesti move together baru dia akan jadi. Okay? Dan ingat, dalam pengiraan haba pendam ini mesti tiada perubahan suhu. Okay? Tidak mungkin dia ada perubahan suhu. Contohnya, kita nak kira perubahan daripada cecair kepada gas. From liquid to gas or water. That means from water to vapor. Okay? Daripada air kepada wap air. Okay? Ia berlaku pada 100 darjah Celsius. Sampai proses itu habis, then the temperature will go up again. That's why you see kamu punya air dekat dapur takkan naik tinggi daripada 100 darjah Celsius, kecuali kamu pergi tambah benda-benda yang lain masuk lah. Tambah garam ke, tambah benda-benda lain masuk. Okay? That's how it goes. Alright? So, let's see the next one. Okay? Soalan pada hari ini ialah, yang ini dia mengatakan bahawa 500 watt electric heater digunakan untuk panaskan satu bikar air. 1 bika air. Hi guys, Alia ada dekat sini. Saya ingat Alia sudah tidur. Very good. Thank you, Alia, for coming over here. Okay, I will turn off the main video for YouTube, and then I will just look at the chat over there. Okay, so if I got disconnected, quickly ping me in the chat. Okay, so let's see ya. Music kacau tak? Music kacau tak? Music kacau tak? Music tak kacau lagi. Yo, esok tak ada solat. Esok memanglah tak ada solat. Oh, good night, baby. Good night. Good night. Okay. Anak saya duk cakap good night dengan saya ya. Okay. So, nyatakan perubahan tenaga. State the energy change that is involved. Okay. Ketika pemanas itu digunakan untuk memanaskan air. Sudah cakap electric heater digunakan untuk panaskan air. Of course, kita akan kata dia ialah perubahan tenaga. Dia ialah perubahan daripada tenaga elektrik kepada tenaga haba. Alright, so the first question is very simple. That's all. You must state ya. Jangan kata tenaga haba sahaja. Mesti state tenaga elektrik kepada haba. Because perkataan perubahan. Change. Okay? Change. When you talk about change, you must have the kepada. Alright? Jangan tulis arrow dalam exam. Okay? So, mass of water. Then specific heat capacity ialah 400 joule per kilogram per darjah Celsius. Initial temperature ialah 30 darjah Celsius. Okay, I hope this one is okay. This is last week's question. Okay. Untuk capai takat didih sudah cakap ialah 100 degree Celsius untuk air lah. Okay, sebab yang ni ialah soalan sains, dia tidak akan bagi kamu benda ni sudah. Alright? So, kamu gunakan formula Q sama dengan MC theta. Alright? So, kamu akan bubuhlah semua formula ni masuk 0.5. And then ada heat capacity of water. Wow, 400. UNT 400 lah. Good lah. Okay. Actually, it's 4,200. I don't know when I type, it's typed wrong or whatever lah. Okay. Maybe ada kesilapan sedikit dan we didn't give it. Never mind. Whatever is given in the exam, we try to do over there. Okay. Even in exam, right, repeat. Maybe you won't get wrong also. Itu ialah kesilapan. Don't worry too much about that. Jangan lupa dekat sini theta ialah perubahan suhu daripada 30 to 100. It is 70 degrees Celsius. Okay, pretty simple over here. Daripada sini, I will have 0.5, 400, 200 times 70 is going to be 14,000. Okay. Yep. Joule. Don't forget the unit. Okay. If you're alright, give me a. Alright. Because I would love to see what's the response over here. Okay. Alright. Okay, cool. Everyone is okay. Right, so let's go to the next question over here. When the water is boiling, reading of compression balance decreases, berkurang 0.0125. The form 5 here, tadi value itu ialah 400 ke 4,200. Please help me check for a bit, okay? I'm not so sure the value is apa. So let's see. Apabila air tersebut mendidih, neraca mempatan berkurang sebanyak 0.0125 dalam masa 60 second. Hitungkan haba pendam. What? That means you have to use Q sama dengan ml. Okay. Berapa Q? Q tadi, soalan tadi diberi Q ialah 500, power ialah 500 watt. Okay. Power ialah 500 watt. Oops. So 500 watt ini kamu kena darab dengan masa 60 saat. Because Q adalah sama dengan PT. M adalah sama dengan 0.0125. Dan kamu ada L. So you can calculate your L adalah. Alright. 500 times 600, 500 times 60, which is equals to 30,000 divided by 0.125. I would think it is rough about 140,000, 240,000, 240,000 or 2.4 million. Something there, okay? Alright. Okay. I would love to see some response first before I continue. $2.4 million. Alright. 2.4 million. Well, 2.4 million is also, we can write 2.4 times 10 to the power of 5 joule per kilogram. Okay, let's go back to a little bit of theory. Macam mana dapat joule per kilogram ini ialah sebab kalau saya tukar balik formula ini, saya susun balik, saya dapat L sama dengan Q bahagi M. Okay, Q atas ialah joule, bawah ialah kg. So this is how I get this formula. Right, rock on people. Right, so let's go to the next question. Okay, so soalan ini saya rasa saya nak skip lah, okay? So saya nak skip, then saya nak straight masuk kepada dia punya calculation. Tak payah saya bincangkan sebab yang ni memang gunakan formula Q sama dengan MC theta, okay? And don't forget one thing is Q ini adalah sama dengan PE, alright? Sama dengan MC theta, okay? So then you will get the answer very easily. Because E adalah sama dengan PT, Q juga sama dengan PT. Because E is energy, Q is energy as well. Alright, so let's go to the next one. Yay! We're moving quite fast today. And then of course you kira kamu akan dapat masa semua. Okay, soalan ini adalah soalan 5 markah. 5 markah. 5 markah bermaksud kalau kamu ganti value semua betul, biasanya ia adalah 3 markah. Alright? And then kamu bagi jawapan betul pun satu jawapan 1 markah. Tapi saya rasa soalan ini distrukturkan supaya ada 6 markah. Tapi maksimum maka dapat 5 sahaja. So it's quite beneficial. Kamu mungkin perlu buat lebih kerja sedikit. Okay? Tetapi maka dia lebih secure sedikit. Okay? Please use this formula. It's quite simple to use. It's quite easy to use because in the future, you just need to remember one formula. Q equals to MC theta. And then the second formula is basically formula daripada bab 2. E equals to PT. Alright? Or Q equals to PT. Okay, and then of course, overall, based on the answer in D, which plate is the most suitable? Yang paling sesuai mesti masa yang paling pendek punya. Saya tak tahu dekat sini, saya tak tahu dekat sini, saya tengok. Saya rasa yang paling elok guna mungkin, I don't dare to tell you because I didn't calculate the question and you shall calculate the question and then you will know the answer. So why not you guys put in the comment which one do you think and which one have you calculated that get the masa yang paling pendek. Alright, and then state one reason, of course, masa pemanasan. pendek. Okay, that is the answer. Simple as that. Okay. So let's go. Okay. Right. Let's go back a little bit. Make sure everyone is okay. Alright, so any response? Any response? Which one masa yang paling pendek? P, Q ke R? Yang kamu sudah kira? Okay. So let's go to the next video then. Is free. It's theory time. So sekarang saya akan masuk gas law sudah. Gas law. Hukum gas. Okay. Hukum gas. Sekarang kita akan masuk hukum gas ya. Okay. Hukum gas theory time. So, saya first one akan cerita tentang hukum Boyle. Hukum Boyle semua dia, the story is this, okay? Dia ada melibatkan pressure dan juga volume, okay? Sekarang imagine this is satu tong air, okay? Satu air dia, alright? Air. Kat bawah, kalau kita tengok hukum tekanan daripada bawah biasanya tekanan tinggi. P tinggi. Ke atas biasanya P rendah. Alright? So you can try to imagine if dekat atas ada dekat bawah tekanan yang mampat dia banyak. Okay, so dia akan dimampat, dia akan diperkecilkan. Okay? Dekat atas dia akan kurang mampatan. Okay? So kurang mampatan, volume dia akan besar, pressure dia akan rendah. Okay? Oops. Kalau dekat sini, pressure dia akan tinggi, volume dia akan rendah. So this is the whole thing is called a Boyle's law. Hukum Boyle. Okay? So that is hukum Boyle. Simple as that only. Dan kita nak tengok. Okay, the next one is called the Charles law. Right? Charles law. So Charles law sebenarnya ialah bagaimana kita nak simplify Charles law is this. Kawasan yang luas, kawasan yang besar. Okay, semua what? Wait, what is this? VT. V dan T. Okay, kawasan yang luas, kawasan yang that is everything that is luas. Okay, kita nak cerita V and T. This is about Charles law. Right? Hey, what the hell? I did some mistake over here. Okay, yeah, this is the one. Sorry. Hey. Okay, so I don't think. Let's not look at these two, okay? So, let's talk about Charles law. Charles law talks about V and T. Okay? Semakin tinggi suhunya, isi padu pun akan menjadi semakin tinggi. Go and imagine hot air balloon. How we inflate hot air balloon? We blow the hot air, okay, kita bakar, and then the air will expand. So that's how it happens, okay? So low temperature, sebelum kita panaskan, temperature dia rendah, okay? So V dia pun rendah, dia tak dapat inflate. So in the end, apabila temperature dia naik, B pun naik. Okay, apabila temperature dia tinggi, B pun naik. So we inflate the hot air balloon. I'm sorry about that mistake over here a little bit. Okay, so I will erase this one. Okay, so let's look at the last one. The last one is called pressure law. Okay, the last one is called pressure law. Pressure law sebenarnya menceritakan dua relationship dekat sini ialah kamu mesti, oh, let's go back a little bit. Okay, so yang ni sebenarnya if P and V is variable, okay, T mesti malah constant. Okay, if this one, oh, what is going on? If this one T and V ialah bergerak, then P dia mesti malah in this situation. Okay, so the last one, okay, as you can see over here, two of the volumes are the same. I think I know why now that one. So dua-dua volume dia sama. Okay, we know here V adalah malah. Yang ni ialah hukum tekanan. Okay, apabila sini sejuk, no problem. T rendah, everyone is happy. Pressure is low. When the temperature increase, the pressure increase. Okay, so when the temperature increases, the pressure increases. Okay, so how it goes, how we want to do the whole formula thingy is we get back to the Boyle's law first. Okay, if P turun, P naik, we know P adalah berkadar songsang dengan 1/V. Okay, so PV adalah sama dengan pemalah. Okay, so in the end, the whole thing, we will have P1 is equal to P2 V2 because P adalah sama dengan pemalah. Alright, so let's go to the next one. Okay, so this one I would love to show you this one. Oh, guys, never mind. Okay, in this case, V adalah berkadar langsung dengan T. Okay, because V naik, T naik. V divided by T adalah sama dengan pemalar is equal to a constant. So V1 divided by T1 is equal to V2 divided by T2. Okay, now the last one. T adalah berkadar langsung dengan P. T adalah T bahagi P sama dengan pemalar. T1 adalah sama dengan T2. Okay, short theory revision. Overall, you can only remember what you can just remember one formula. Then you can settle everything. Okay, so this formula is a little bit advanced. We call it the universal gas law. Okay, you can write it down. Actually, I'll give you the formula over here right now. Okay, but let me clear this screen first. Okay, so this one actually we learned in Form 6. Yeah, is use P1 V1 divided by T2 adalah sama dengan T2 V2 divided by T2. Okay, and also comes from this formula, PV is equal to nRT. So PV bahagi T adalah sama dengan nR, dan kedua-dua ini ialah pemalar. Okay, PV divided by T sama dengan pemalar. That's how. Okay. Alright. If you remember one formula, of course it's easier than you remembering three formula. Although formula ini. Okay. I hope this formula really benefits you, and you can have a look. Okay, I'll have a little bit of pause over here so that you guys can see and jot down some notes if you need. Okay, let's move on to the next question. Diagram shows air bubbles produced by an air pump in an aquarium filled with fresh water. Okay, gelombang-gelombang udara dihasilkan oleh pump udara di dalam sebuah aquarium berisi air tawar. Okay, so as usual, you can see this thing come out sudah. You know sudah ini confirm tengah cakap pasal Boyle's law. Okay, bubble, 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 boil, bubble, boil. B equals to B. Bubble and boil, they are the same thing. Okay. So let's go to the next one. Explain why berterangkan mengapa isi padu gelombang udara panas bertambah apabila bergerak menghampiri permukaan. Okay, let's look at this. Of course, the first thing you have to cakap ialah menghampiri permukaan, kedalaman, menurun, tekanan, menurun. Okay, that is one answer. You can also say kedalaman berkadar langsung dengan tekanan. You can, and then you can talk about tekanan berkadar songsang dengan padu. Okay, so this whole thing only got 2 marks, and basically you can choose either this one, right? Okay, kedalaman dengan P ataupun kedalaman berkadar langsung dengan tekanan. You choose one, then you write. So apabila tekanan turun, padu meningkat. Okay, so 2 marks question. Name the physics law involved. Boyle's law, hukum Boyle. What is the change in volume? Apakah perubahan dalam isi padu gelombang pada paras R apabila air tawar digantikan dengan air laut? Okay, so specifically dia cerita pasal dekat R. Alright. So you have to go back to this formula. You have to go back to this formula over here. Oh my god, someone asking. Sorry guys, no, you guys cannot. Okay? I can no worry. Okay, so P is equal to H rho G. Alright. So air tawar dengan air laut. Okay, kita bandingkan ketumpatan. You know, air laut lebih tinggi. That means ketumpatan dia naik. Okay, ketumpatan naik, that means, so daripada formula ini, P dengan rho, P adalah berkadar langsung dengan rho tekanan, maka tekanan dia akan naik. Okay. Jadi, tekanan dekat R kalau ganti dengan air laut sudah, tekanan dekat R sudah naik, means isi padu dia akan turun, berkurang. Alright, isi padu berkurang. Let's go to the next one. This is a very tricky question. I think some of you actually is quite difficult for your level to do, but it doesn't matter. Let's see how it goes. Yeah, an air bubble of volume 5 centimeter cube is released by an air pump at the depth of 0.5 meter. Calculate the volume of air bubble when it reaches the surface area of the water. Okay. So, dekat sini kita kena tahu satu benda dulu. Okay? Dekat permukaan air, dia kata dekat permukaan air, sini ialah 10 meter H2O. Okay? 10 meter air. Dia kata tekanan sama dengan 10 meter air. Okay? So, apa maksud dia ialah, we have to prepare the formula. P1 V1 is equal to P2 V2. Right? So, at the depth of 0.5 meter. Why it says so? This one go down 0.5. 0.5 bubble here. This one tekan atmosphere, tekan dari atas ialah 10 meter. Ini ialah air. Kita anggap ini ialah 10 meter. Air juga. Alright? So, sekarang saya nak bahagi dua bahagian. Sini ialah sini ialah situation 1, sini ialah situation 2. Okay? So, P2 dekat sini ialah 10 meter. Okay? P2 dekat sini ialah saya tak tahu. Okay? P1 dekat sini ialah 10 plus 0.5. It's because at this point, saya kena tambah tekanan daripada sini dengan tekanan di sini. Tekanan daripada atmosfera ialah 10 meter air. Tekanan air itself is 0.5 meter. Okay? Dekat permukaan air, sini ialah 10 plus 0 sebab dia duduk atas permukaan. So, it's 0. Alright? And then we have V2. V1 is over here. 5 cm cube. Yang ini tak payah tukar dia punya unit is because ini ialah soalan berbentuk nisbah. Dia berbentuk nisbah. And so how it goes is you have to just, don't forget the bracket guys. Don't forget the bracket. Bracket very penting here. Okay, you have 10.5 times 5 and then you have 10 divided times V2. Okay. 10.5 times 5 is 52.5. 52.5 divided by 10 is V2 is equals to 5.25. Don't forget this kind of question. If it's not in SI unit, please put your unit. Don't forget your unit, guys. Right. Centimeter cube, yeah? My writing is a bit lousy. Okay, so let's go. Next one. Okay, so diagram 1 dan 2 shows trapped air in two identical flasks. 5.1 menunjukkan udara yang terperangkap dalam dua kelalang serupa yang dipanaskan dengan kuantiti haba yang berbeza. Okay, so daripada sini kamu boleh nampak sini ialah bubur dekat tengah-tengah, sini ialah bubur dekat maximum. Alright, maximum. And so maximum how it goes is maximum always haba dia lebih lah. Okay, so kita boleh anggap kalau dua-dua ditutup selepas 10 minit, confirm ini suhu lebih tinggi lah. Confirm ini suhu lebih rendah. Okay, so kita tahu sudah. Alright, so the next one. State the physical quantity measured by Borden's gauge. Tolok Borden. I'm sorry, tolok Borden kita tak dapat guna dalam eksperimen dekat sekolah. Because the tolok Borden in sekolah sudah jadi tolok. Okay, so don't end the slide. Don't end the slide. What going wrong, guys? Okay, so apakah yang diukur? Dia ialah tekanan. Okay, pressure. It is measuring the pressure. Compare the readings of both Borden's gauge. Oh, see that? Doesn't matter. Doesn't matter. The error over here. Okay. Compare the readings of both Borden's gauge. Okay. Bacaan dua-dua Borden's gauge. Bacaan diagram 1, Raja 1 lebih daripada Raja 2. Tak cantik loh. Raja 1 lebih daripada Raja 2. Okay? What am I thinking about? Raja 2 lebih daripada... Right. Okay. Raja 2 adalah lebih daripada Raja 1. So you can make the sentence lah. Tolok Borden dalam Raja 2 adalah lebih daripada Raja 1. Okay. Let's go next to question. Bandingkan bacaan termometer. Termometer Raja 2 adalah lebih daripada bacaan termometer Raja 1. Okay, you can't see the writing. Thank you. Okay, thank you very much. I'll use blue color. Blue. This is bad. Orange, okay. Use a thicker blue. All right. Raja 2 adalah lebih daripada Raja 1. Okay. I hope this is better. Okay. Alright, I'll try to improve from time to time based on the apps that is given because I'm using Microsoft PowerPoint over here. I'll try other new apps when I have time to actually explore more. Yeah, guys. So I will improve from time to time for your benefit. Okay. So state the relationship between heat supply and the temperature. Relationship. Apabila dia kata relationship, you mesti guna perkataan seperti berkadar langsung, directly proportional. Ataupun you go for the word, paling traditional word, you use semakin. Okay, semakin bandingan. Okay, so I would over here actually say, or you can actually go for meningkat dengan. Okay, increase with. Alright, you can use that also, but that is a little bit harder to use. Okay. So I wouldn't quite recommend you to use that word, but I would always use semakin. When increases, increases. Okay, so let's see over here. You can see very clearly apabila temperature meningkat, suhu meningkat, tekanan meningkat. Okay. Noise. Alright. So state the relationship between pressure of what am I writing? Too fast, guys. Fast. Dia belum tanya lagi pressure, saya sudah nak start tulis pressure dah. Pressure betul lah. Okay. Heat supply increase, temperature increase. Okay, simple as that. Heat supply increase, temperature increase. Please, in SPM, don't use short forms like that. Okay, state the relationship between pressure of air in the flask and the temperature. Pressure of air and the temperature meningkat, pressure meningkat. Okay? Simple as that. That's all. Based on kinetic theory, explain the reason for the answer B4. Oh my god, this is such a difficult question. Alright. Based on theory. What are you talking about? Pressure. Kinetic theory, okay? Kinetic theory. Kinetic. Okay? It's very easy. The word sounds big. It's not so difficult. So kinetic theory kita tahu bahawa suhu meningkat. Okay? Kinetic energy EK, alright? Untuk molekul meningkat. Maka molekul bergetar dengan lebih laju. Apabila molekul bergetar dengan lebih laju, dia hentam atas permukaan flask. Okay? Permukaan kontainer itu, dia akan langgar dengan permukaan kontainer itu dengan lebih kuat. Alright? Home. Lebih tinggi, lebih kuat. Maka, pressure akan naik. Okay, so where do you score the points? Well, talk so much, where do you score the points? Okay, you score the points here. Right? Score the points here. One bonus point. One bonus point. If laju naik, that means momentum juga naik. Okay? Momentum naik, that's how the pressure naik. Okay? You can write V naik, you can write momentum naik. Laju bukan laju biasa-biasa. Laju jirim. Okay? So let's recap. Apabila menurut teori kinetik, suhu naik, tenaga kinetik molekul-molekul jirim naik, no problem. Okay? Maka hal laju atau momentum jirim molekul-molekul, then pressure naik. Okay, so that's all. Simple as that. Right? Because, because EK is equal to half mv square. Of course, tenaga kinetik naik, hal laju akan naik sebab jisim ini tetap malar. So, you good? Apakah pemboleh ubah dimalarkan dalam eksperimen ini? Just now, T naik. So, V adalah V adalah malar. Apakah hukum fizik yang terlibat? Hukum So basically that's all for today, and I hope you guys do not have questions. I'll hang around a little bit more. I'll end the live stream a little bit more, so you guys can ask questions if you need to. If you do not have questions, if you want more challenging question, this is the time, because I'm going to give you more challenging question from now on. Because next week onwards is essay question. Yay. Go and get your friends to come here and to come into this channel to watch a little bit, so that the more the merrier. I hope the chat over there is a little bit more busy, more people typing, more people using laptops instead of using a phone to watch. Okay, so yeah, if you really like the video, please put a like on it, and if you are watching the replay, do give a like on it and share to your friends if you want to. Also, the last but not least, okay, you have any questions, do not forget to email me in my channel descriptions email. I will try to answer back to you as soon as possible, or I will take the question out to discuss in the live stream itself, okay? And hope that everyone will benefit from it. But please, if you want to email me, please email me on Thursday before 12 p.m. Do not email me on Friday. Okay? So thank you very much and see you now. Bye.
say you can't hurry love. No, you just have to wait. She said love don't come easy. It's a game of give and take. You can't hurry love. No, you just have to wait. Just trust in a good time, no matter how long it takes. Now how many heartaches must I stand before I find the love to let me live again? Right now the only thing that keeps me hanging on when I feel my strength, oh it's almost gone. I remember my mama said you can't hurry love. No, you just have to wait. You can't hurry love. No, you just have to wait. Now love, love don't come easy, but I keep on waiting, anticipating for that soft voice to talk to me at night, for some tender arms to hold me tight. My mama said you can't hurry love. No, you just have to wait. She said love don't come easy. It's a game of give and take. You can't hurry love. No, you just have to wait. Just trust in a good time, no matter how long it takes. And how many heartaches must I stand